Good morning, everyone. My name is Ali Ben-Bir, and the name of the company is MMD. First of all, I'd like to thank everyone for being here to listen to us. We've only got 10 minutes, so it's just enough time to introduce you to our company and our products without going too much into details. But I'm sure in the next 2 days, everyone will have the opportunity to come and talk to us and ask us about what we do and how we can be useful for whatever projects you might have in the future or currently. Okay, so I think we're all ready now. So basically, we're the world leaders in the design and manufacture of what we call sizers, which is a type of crusher that existed since 1978. We're the founders, and we had a patent to this kind of technology for over 20 years, and now it is in the public domain. So over 45 years, we've developed this product to the state it is in now, and that's one of the reasons we called the company MMD, which is Mining Machinery Development. So we've never stopped developing our machine. We've also grown as a company from a few people to a multinational organizations now with 6 manufacturing plants and 18 offices worldwide. We've got about 600 employees today and a big number of machines installed in over 120 countries. So this is just to show you where we are present as offices and manufacturing facilities. And these are just pictures of these facilities. So we're in China. The main one is in the United Kingdom. The one that we built after that was China, then South Africa, then India, then Australia, and we're in the process of setting up another facility in Chile. So we offer tailored solutions, and we have a proven big list of references. Capacity and equipment longevity is a thing that MMD like I said, the technology is always, we've never stopped developing our technology, and now what used to be a coal machine is a machine that can handle any type of material with any strength, any hardness and any abrasiveness at high throughput in difficult conditions. We've got all the certification, all the quality, ISO certified, as you can see on the slide. So key products basically is the sizer, which, as you can see, is a twin roll crusher, but very different from the conventional classic twin roll crusher that everybody knows around here. So like I say, it was invented in 1978. We built 3,000 units or over, installed and successfully operating in different types of materials in a number of countries, achieving capacities up to 12,000 tons per hour. This is a video that shows you how the machine works. So it's a slow rotating shafts. You can see that the only material that we really break is the oversized material, and all the fines that can pass through the space between the teeth will pass through the space between the teeth, allowing the machine to achieve high capacities with a compact size. It also handles sticky material, hard material, or a mix of both. It can be fed directly by a front-end loader or a shovel, as well as fed by apron plate feeders. This is a comparison in size with other machines that do the same capacity. So it's a very compact machine, ideal for fixed, semi-mobile, mobile installations. We also do our own feeders, which has got some plates that are made of rolled steel, very resistant to impact and flexion. So we use the feeder and sizer to build fixed, semi-mobile and fully mobile installations. These are a few examples of fixed sizer installations. Semi-mobile installations where there's no concrete. And then a comparison in size between a typical gyratory and a sizer as a primary. I'd like to finish with this video that shows you how we move our semi-mobile installations. Audio? So semi-mobile installations are modular installations that can be relocated using our own manufactured transporter from one location to another to keep the haulage distance for trucks as a minimum and reduce the truck fleet and improve the environment and costs. So each module is transported separately into the new position, reassembled, ready for working again. We've got 1 more minute. I hope this will be finished by then. So I think we've come to the end. Thank you for your attention. If you have any more questions about our product, our company, please don't hesitate to come and talk to us direct. We have a stand in the exhibition, 48, stand number? 4849. So you're welcome to come and ask us questions. Thank you.
Good morning, ladies and gentlemen. My name is Esko Tahkola, and I do come from Sidra Minerals Processing, and I'm presenting solutions developed by Sidra to optimize the operations of concentrators. Sidra is an American company and has been working for mining already for over 20 years. It's behind sonar flow monitoring technology and particle size measurement directly from every hydrocyclone to optimize the grinding for coming process stages. And now we are also introducing the P29 process separation technology, which is enabling coarse grinding and efficient separation after that, replacing the rougher flotation. Our first product was passive sonar flow measurement for slurries. The earlier solution was to use magnetic flow meters that measure the ion flux through a specifically shaped magnetic field, assuming that the ions in the material are distributed evenly. But of course with slurries they are not, so that's a problem for that technology. With SonarTrack we are measuring the propagation velocity of the turbulences that carry the solids forward. So we are providing the real information of the flow, production flow. We also get lots of process diagnostic information there, and we can provide additional information to optimize the process runnability with this multi-measurement device. It enables also remote diagnostics because we can take measurement copies with USB sticks and analyze those ones remotely. Here you see a comparison of sonar and magnetic flow meters, similar meters installed on both ends of the line, and you can see the effect of density variation, so the material distribution on this magnetic flow meter measurement result. Additional information we get with sonar is the air content measurement, the volume occupied by bubbles, and we can correct the errors those ones are causing for density measurement. We are also monitoring the flow quality, so we can prevent line blockages and disturbance situations based on that. We are also monitoring the sound pressure level there, so it gives information of the operational stability of the pump. So it's nowadays a standard solution for slurry lines. Already over 700 concentrators in the world utilize Sonatrax in 72 countries. So the second product is the Cyclonetrack PST, particle size measurement directly from the overflow of every single hydrocyclone in a battery. The conventional way there has been to take samples for analysis from the consolidated flow of hydrocyclone battery. That's not real time, and the representativity is very poor, and it's assuming that all the cyclones in the battery are operating similarly, which is not the case. Additionally, they have a different kind of equipment monitoring systems that monitor the cyclones, but they are not measuring the product. So now we do have a real-time measurement directly from every hydrocyclone, so it's very representative and real-time solution for that. It's simply an acoustic waveguide that the particles hit, and that impact is then calibrated into particle size measurement result. You can follow 5 different particle size limits in real time. Based on that, we can control the grinding to produce optimal particle sizes for the next process stages like flotation or leaching, and make the grinding more efficient to maximize the throughput and get the recovery optimized at the following stages. And based on that, we can do control trade between throughput and the recovery to optimize the net metal production. Our customers have reached up to 10% increases in net metal productions of concentrators. Here you can see trends operating there, and you can see that the single hydrocyclones are not operating similarly, and they are also affecting to the operations of each other. Based on that, we can monitor how each hydrocyclone separately is working and make it optimal. Here we see typical reports, weekly reports provided by our system, so the particle size distributions and the variability of the particle sizes that each cyclone in the battery has produced during the week. If you are having roping events happening there, so that of course is a big failure for the recovery. Here we have a case of an 8-cyclone battery, and 1 cyclone is roping. It means that the recovery is dropping already 7.4%. Here we have real data from a customer case where the PST-based control has blocked out 5 different roping events during 40 minutes time. Here is a case study from the biggest copper mine in North America, and there they run tests for 6 months to grind to the same particle size with same targets based on PST control and based on old system. And the result was that with PST control they got 10% more production, which was value about $60 million per year. So the classification circuit after grinding is really the process area where you can increase the net metal production of facilities. So the primary benefits are that we are optimally operating individual cyclones, and grinding, the whole grinding circuit is optimized for following process stages. And there we can do control trade to maximize the net metal production of the concentrators. And we are preventing all the roping events there. Secondary benefits is the reduction of specific energy consumption per ton produced, because we are maximizing the energy used for grinding in mills. Water usage is slightly reduced, and of course we will get reduced process variability there. Now we are introducing also the P29, which is a step change in minerals processing efficiency. Instead of air bubbles, we are using sponges to capture the minerals. And based on that, we can catch up particle sizes with minimal mineral exposure up to 3 millimeters instead of that 0.2 millimeters of gained by flotation. So based on this, we can optimize separately the capture of the valuable minerals, the transportation of the minerals, and the release of the wanted materials there. So it's a really efficient process. Here we do see those sponges. The porosity of these sponges is tuned to capture the particle sizes that you want to have over there. And with those sponges we get high attraction forces and can tie those wanted particles and make a really vigorous washing to get the gangue out from the material already in early stages without using energy to grind that further. We get high mass pull versus a very good upgrade ratio. So we can do recoveries with very low mineral exposures, even below 1%. And you can see that when we do add these contact rounds, there we can tune this recovery to the wanted level. You can see here that even after 10 contactor rounds, the upgrade ratio, so the amount of valuables in the outlet is 4 times higher than in the inlet. So based on that, we can continue the tuning of recovery to whatever level you want to have it. This is the process. Simply, so there's the coarse feed going to the contactors. Contactors are simply rotating drums where we mix the sponges and the minerals. And the loaded media is taken there further to be released by release agents in mineral recovery. And the washout material goes to the next contactor, and there are so many contactor rounds in a row that you reach the wanted recovery level. So very simple machinery there. The mineral recovery, you can simply use pumps to shake out the wanted minerals from the sponges, and then you wash it away, and there's a release agent which is biodegradable that we are using there to get the minerals out there. And then the concentrate goes to regrind circuit and most likely to clean flotation after that. So now if we are able to grind up to, instead of P80 value being from rising that from 150 micrometers to 500 micrometers, we are already saving 50% of the specific energy used for grinding. And of course, the other possibility is that if you are having an existing process, so you can increase the capacity in the grinding, so increase the throughput by that corresponding amount. Further on, we are providing coarser tailings, and it means that the water recoveries from that will increase. So if once again we increase the P80 value in the tailings from 150 micrometers to 500 micrometers, then we already triple the water recovery. Huge savings in the water consumption. This is the process, so we are typically capturing, for brownfield case, so we are typically capturing the wanted particle sizes from the underflow of hydrocyclones for the P29 process, and then the customer can also simultaneously optimize the existing flotation for the fines flotation there. And then after these processes, there's the normal cleaner flotation stages after regrind. With greenfield applications, basically we can nowadays reach by grinding with crushers down to 6 millimeter particle sizes, and now after that we need only P29. After a couple of 1 or 2 HPGR mills or 1 VRM mill there to go there. So no grinding section anymore needed inevitably. Or the other alternative is that with P29 we just replace the rougher flotation and utilize the old grinding systems there. If you wonder what the P29 means, it's the atomic number of copper. So we have developed this technology with copper, copper producers. But of course, this is suitable for all minerals where you can use flotation, and even to further developments for other processes. So this enables grinding to larger particle sizes, and that can increase the throughput of the existing grinding circuit by up to 40%. It enables new energy efficient process solutions for greenfield new concentrators. It enables recoveries from less than 1% mineral exposure of the particles. It dramatically improves the throughput and economics of an existing mine site without the cost of a new costly energy consumption grinding line. It's fast process, over 90% recovery to reach in less than 3 minutes process time. It optimizes the existing flotation process for the fine particle recovery and enables coarse particle recovery through the P29 process. It lowers the water usage significantly by improving the water recovery, and of course reduces the energy consumption per ton produced. We also deliver coarse particles for the construction of tailings dam walls, so they will be more stable. And it can be applied to all minerals where flotation can be utilized, and it's really versatile in its ability to selectively capture the targeted minerals. So it's a natural complement to an existing mine site and ready to be taken in use. Here we have a case where we have calculated the value impact of this for comparing traditional SAG mill, ball mill circuit grinding with rougher and cleaner flotation concentrator with HPGR combined with P29 coarse recovery and flotation for fines and clean circuit. So the total installed cost, this is a case calculated for 10 million ton per year production copper mine in Australia. And so the total installed costs are reduced by 13%, but the total comminution power consumption, you can see that it's reduced more than 60% there. And the net present cost of comminution circuit for over 20 years they are estimated to be 44% less with this P29 HPGR combination compared to the conventional solutions. So we are here in this hall, our stand, Sidra. You are welcome to visit us to discuss more about our solutions to optimize your processes in whatever stage your process developments and projects and productions are. Thank you very much.
Следующий выступающий.
Next person to speak is Filipe Dili, consultant on OpTech development. You are welcome. Здравствуйте.
My name is Filipe Dili. It's a great pleasure to be talking to you today about MapTech products and how they can help mining companies to produce more efficiently and more cost efficiently as well, using our technology, which is going to be the focus of today's presentation. So this presentation was prepared based on a certain target audience. So first of all, let's check if you're part of this target audience. If you are, then that means that MapTech products are designed for you or for your company. First of all, we have been understanding that geology, deposits, and operations are getting more complex as the years go by. They're typically getting more difficult to work with, so we have been designing our products to fit this complexity, both in terms of geology and in terms of operation, so technical services in general. When it comes to technology, we clearly see mining companies splitting in two different groups. The first one really embraces technology. They see innovation as a way to perform better, to achieve higher results. And a second group that is more resistant, that prefers to keep with traditional procedures, standards. So if your mining company belongs to the first group, then this presentation is for you. Another very common point that we have been seeing globally in mining companies is a struggle to find and keep qualified professionals, both geologists, mining engineers. They're getting very rare and hard to keep. So what we do as a technology provider, we adapt to this by making our technology moving towards automation so that we can use the time of these qualified people really in the key tasks that require high qualification, so moving away from manual tasks, from repetitive tasks as well. Last point, you typically as a mining company want to spend less with technology, not invest even more, but even so getting better results. So if these points fit your company, then this presentation is for you. Just a quick overview about who MapTech is. We're a global company, more than 40 years in the market providing technology to the mining industry. We have 24 locations worldwide and about 400 employees. So these are some of the numbers of our company. We target our customers' main business, core business is mining, and our role is to produce technology to serve these mining companies. That's what we do. To serve these mining companies, we structure ourselves through products. So I'm going to speak very quickly about each one of these products. I'm going to do a quick pitch about each one of them, and then after a few minutes, you will understand if they're a good fit for you and which one is relevant to your company. All right. So starting off with Vulcan, a very consolidated product. It's been around with more than 40 years. We have more than 25,000 licenses globally. So it's an all-in-one package for you to do your geological modeling and mine planning, all in one. So you can go from geological exploration, modeling, geological estimation as well, with all the simulations and krigings and geostatistics from your mine planning, so open pit planning, stratigraphic mine planning, underground mine planning, and sequencing as well. Everything in one package. And another great benefit, besides the great features of Vulkan, is the licensing flexibility. So typically, most companies have big packages, so they have one big package for geology, another big package for long-term planning, another big package for short-term planning, so they have to invest a lot in each one of these. Instead, in our licensing mode, what clients can do is they have one Vulkan seat, one Vulkan license, and then when they want to do their pit optimization, for example, they just add this module. It can be for a short period of time when they use it, so they pay exactly for what they use, and they pay just for the period that they use. So it's a very flexible licensing combination, which makes the product very cost efficient as well. Apart from Vulkan, we have our geology core. So it's our product to simplify or streamline geological modeling workflow. So typically for production geologists that just brought new data and want to run their geological modeling quickly, Geology Core is the solution to do so. It has implicit modeling, it has machine learning approach to mine modeling in general. And essentially what it provides is a big number of scenarios, and then your geologist can quickly look at the results and see which one makes more sense and kind of guide the software to work in the direction that you're looking for. Working alongside with Geology Core, we have Domain MCF. So Domain MCF works as an algorithm inside Geology Core. It's a very rapid, accurate resource modeling solution. And it uses cloud computation, so it runs very fast and produces very accurate domain models, which you can then translate into Vulkan and continue the mine planning workflow from this geological model. Moving away from geology and entering the engineering area, Evolution is our big suite for mine scheduling. So it has all the solutions for long-term planning, medium-term, so strategic planning, tactical planning, and operational planning, all in one package. So if you're doing long-term planning with Evolution or long-term scheduling or sequencing, typically you focus on strategic decisions such as NPV optimization during scheduling, CapEx balance with OpEx throughout the life of mine. Whereas if you're doing more production scheduling, so in the field doing your monthly planning, then you're typically going to use the features that target the better utilization of existing resources. So the plan is defined, we're all aligned, now we need to execute it. What is the best way to use the existing resources? So machinery, people, all the resources that you need, and that could be a constraint for your production plan. You balance these and make sure you're following the right strategy. This is all within Evolution. Now moving away from the planning space and entering the operations space, so in mine operation we have MapTech resource tracking, so our material MRT. Essentially it is a solution to transfer the ore body knowledge from your geologists, or geologists make very good and very complex geological models, but many times we see that we don't use all of this knowledge for the operation, and the result of that is reduced recovery at the processing plant. So what Material MRT does is it connects the knowledge from the resource model or the production model, it collects information from your fleet management system and different sensors that you might have in the process or in the conveyor belts, in the crusher, connects all of this into a single system that targets real-time insights for your operation to adapt to the recent information and improve blending. So it's a product targeting companies that have complex blending requirements and that struggle to meet the recovery at the processing plant due to I can say poor management of the material in the mine. Blast Logic is our very complete solution for blasting, open pit blasting. It was developed in association with the mining industry, so as per request of our biggest clients. Essentially connects all the different data coming from different sources in the drill and blast workflow and uses this information to perform better blasts. Vision V2X is our safety system for underground mines, our collision avoidance system or proximity awareness system. Basically, if you're driving your car or your truck underground, you have a tablet in the truck and then you detect the presence of other vehicles or other people without the need for any infrastructure. So that gives you improvements in terms of safety and traffic management in underground mines as well. Trying to go quick here. So Geospatial Manager is a very simple product. It's our data host, online data service for survey surfaces. So kind of a repository for survey. Sentry is our geomechanical monitoring, we can put it like that. So you can monitor the slopes in the mine and detect any movement, even if there are small movements, through our laser scanners. So we also have laser scanners that can be used for geotechnical monitoring or for topography as well. Benefit of using our laser scanners, you can also use our software for survey. So we design both the hardware and the software. You can use them in combination or separately. So if you use Point Studio, you don't need to have the scanner. You can import data coming from drones if you want and create all of your survey reports. Most of our solutions, they're in a web-based platform called Workbench, where you have access to our help, to new licenses. So if you want to just hire one additional package for 1 day or for 1 month, how much time you need, you can just go to our MapTech store. It's online. You click it, you use a credit card, get it paid, start using right away. So it's very flexible. We try to serve our clients in the best way that we can. Last solution that I'm going to present is our most innovative, the new solution that we have. It's called Vectrix. So it's a combination of 3 pillars. First one, data management. So MDS, the MapTech data system, allows you to host data in the cloud, integrate this data, transform to different formats, so you don't have problems with transforming data from one format to another. Then you can use MCF, which is our compute framework, which is essentially a big availability of our algorithms developed through the years, available also for processing in the cloud. So you can run pit optimization, grade control model generation, implicit modeling, everything in the cloud very quickly with data that is managed in MDS. And all of this is orchestrated by MOE, where you create your own workflows. You can trigger human-in-the-loop reviews, so you can say, oh, every time there is a new drill hole data, for example, you trigger this implicit modeling generation, you generate 10 models, you send it to your geologist, they check it, they say, oh, this one is better, and move forward to the next step of the workflows. So you define this environment and these workflows and how they should be. Last but not least, our services. So most of the software companies are moving away from services, but we believe that services are important way to serve our clients. So we do keep very qualified people to provide very good training and very good services, or consultancy services, or executing services for you in general. Right. That's it. Thank you very much. We're available to talk to you in our booth. Thank you very much.
Thank you very much. Следующий выступающий.
Next speaker is Oskar Kazhagul, the representative of Nippon Eric Company.
Добрый день.
Good morning. My name is Oskar Kazhagul. I represent the company Nippon Eric, the manufacturer of the original equipment of tower mills. First of all, I would like to thank the MINEX organizers for providing this opportunity for Nippon Eric Company to present the issue of decarbonization. I will be presenting two schemes of grinding. I will be talking about the traditional grinding and the new technologies ensuring effectiveness and flexibility. So a couple of words about the company. Eric Company is the manufacturer and supplier of the breakthrough technologies in the area of grinding, so mixing, granulation, drying. These are in the mining industry and metallurgy. Eric Company is well known by supplying mixes that are used in the agglomeration production, in recycling of metallurgical wastes. And the second product, tower mill for fine grinding. Ernst & Young Company defines 10 main risks and opportunities in 2025 for mining industry. Out of 10, I picked up 6 risks that are related to the grinding. Grinding is the core of any mine and of any concentrating mill. It has a great impact on the production and for the cost effectiveness of the operations. So the increased cost out of 10 risks and opportunities, for the mining companies, first of all, we are talking about the capital, environmental, social, and governance ESG issues, and then the license for operations. But the cost increase and productivity is one and another business risks, because the mines are working in the remote areas, the pits are more deep, and the hardness of the ore is increasing, the cost of the labor force is increasing. And then climate change is also a risk, and innovations in the mining industry, especially the usage of the energy efficiency systems and the shift to digitalization, provided us opportunity to reduce these business risks. And we are proposing the favorable solutions, comparing with the traditional grinding schemes. As I mentioned already, when we are grinding, the main problem is the changes of the ore. The finds of the minerals. These problems provides problems for the concentrating plants, requiring big costs for the energy and water, requiring capex and opexes, and at the end, everything results into the higher emissions. For example, traditional scheme of the concentrating plant, you can see on this slide, you can see the 3 stages grinding in the roll crushers with the magnet separation between the grinding stages. And so the coarse is about 30 microns. The technology used in this traditional scheme is energy consumption, energy intensive, and doesn't have any flexibility. To take into account the variability of the ore. This scheme is still operational, but at the same time we have new technologies that can propose more effective solution in terms of sustainability and in terms of decision making.
The objective to reach zero emissions in 2050 is seriously perceived by all the parties concerned in the mining industry. The key thing is that decarbonization should be agreed and aligned with sustainable production of resources and profitability of businesses. Otherwise, we will not reach progress as a sector. How we can reach zero emissions in 2050, ensuring profitability of business and having preserved the sustainability of resources production. The key word here is a balance. One of the ways to start is implementation of new technologies in the new projects and in the current projects, both in greenfield and brownfield projects. The technologies that can contribute to decarbonization are the rules for grinding HPGRs, we used to call them. Ball mills with mixing and fine screening. I'll talk about the mill, Erichtau mill, that allow us to reach zero emissions in 2050. As it has been already mentioned, Erichtau mill is a vertical ball mill with mixing, which has been used in the mining sector for 40 years. This technology has a lot of advantages in comparison to horizontal ball mill. Our mill may substitute the ball mill at the secondary and third stage of milling. The advantages of Erichtau mill include low cost of ownership, mostly on the economy on OPEX. That includes energy and milling balls. Capital costs are comparable, but in some projects they are 6 to 7% lower if compared to horizontal ball mill in the similar grinding regime. Operational flexibility. The capacity of tower mill can be increased or decreased depending on the needs in energy for grinding and characteristics of the ore. High operational preparedness, ensuring high throughput of the concentrator. The most important thing, MINEX company produces tower mills in accordance with the requirements of the project, but not the same design for all. There are lots of constructive specifics that are considered in different projects. I will be happy to discuss them in offline mode if you got interested. As an alternative, MINEX proposes a new scheme that excludes horizontal ball mills and substitutes them with HPGR and tower mill plus fine separation screens. These tests of SMC have been used as a basis for this analysis. The ore is very significantly variable as the working index of bond is variating within 16 to 22 kilowatts. This is a traditional scheme with three-stage fine grinding and magnet separation between the stages. The size of the feed roar in the first stage is 25 millimeters, and the product in the first stage is 60 micron, the second stage 63, the third 30 micron. Pay attention that in the ball mill, big milling balls are used for such grinding, which is believed not to be efficient. As an alternative, MINEX proposes to use HPGR tower mill. HPGR will accept a raw material of 32 millimeters from secondary crush and decrease it to 2.1 millimeters. The first stage tower mill receives the raw material of 2.1 millimeters, and all the other components are the same, and the separations stages are the same. Pay attention that in tower mill at every stage of grinding we use smaller milling balls if compared to ordinary ball mills. It was selected from the coarseness of the product. The advantages of the scheme. The analysis proves that proposed schemes HPGR and tower mill ensure consumption of 30% less energy in comparison with traditional scheme and 45% less molding bodies and CO2, which are 45% less. On top of that, the scheme ensures operational flexibility as tower mill can decrease or increase consumed energy depending on the variability of the ore. How it can be achieved? It can be achieved on efficient fine grinding in tower mill. Usually 30 to 35% of energy, they are more 35 energy efficient than our traditional mills. The use of HPDR for energy efficient milling with the finest supply at the stage of milling. The sieve decreases to remove the inefficiency of taglines. Opportunities and guarantees. The guarantee of production is an important topic of development in Nippon possesses the following opportunities for accurate design and identification of the sizes of the equipment, ensuring a low total ownership cost. The first is a test for finding tower mill to identify the volumes of energy. The second test identifies the characteristics of the ore to identify its variability. Modeling and simulation. A big database from operational data allow us to make a comparative analysis. To develop the schemes and solutions, Nippon Iron cooperates with original producers, OEM, and engineering companies. We carry out preliminary design and planning of equipment. We use our experience and database in international projects. Making a conclusion, we can say that decarbonization with profitable operation is a win-win situation for everyone. Such equipment as HPGR and vertical ball mills with mixture tower mill and thin screen can allow us to reach zero emissions in 2050 as this equipment is efficient. Understanding of ore body to develop efficient and flexible granting scheme is a key to decarbonization. Cooperation of all the parties concerned is very important for sustainable recovery of the resources. Thank you. Thank you very much, Oscar. And the next presentation is Anna Conceptor, consultant from Crystals.
Hello, everybody. For those who don't know me, I am a geological consultant, but I'm here representing the Society of Economic Geologists, for whom I hold a volunteer position as the regional VP for Central Asia, so for this region. And our goal is to provide good geological knowledge at zero cost, particularly to young geologists, recent graduates, and students. But I'm here to talk about lithocaps today. Lithocaps are blankets of silicic rocks that form up on top above porphyry and epithermal gold deposits. They are really residual quartz that form from very acid fluids having gone through a fault, having gone up a fault, dissolving all of the rock that was in that encounter, dissolving it into a sponge-like thing, that rock that has nothing left but what was already very silicious, which was already very acid, which is silica itself. So there we see the feeder zone. The feeder is that structure of just silica. And when those fluids reach a very permeable lithology, they start spreading sideways to form a blanket of that silicious rock where there's nothing else left. Those fluids just corrode everything else. So we end up with these large outcrops of residual quartz that can be kilometers wide. And beneath them, there's a very recessive layer of kaolinite, particularly, but clays. And those clays will tend to erode very easily. And the silicification on top is very hard. And it breaks into big blocks of silica float, which seem very interesting, very attractive to exploration. But in reality, that silica is barren. Lithocaps are very barren, and as a mineralization potential, the mineralization potential in the lithocaps is minimal, unless you can find a feeder. But as an exploration tool, they are really useful to go look for porphyry and epithermal deposits underlying them or lateral to them. Lithocaps in the Soviet literature are called secondary quartzite. And that term was used since the 1800s, but it really became popularized since Nakovnik published the seminal book «Вторичный кварцит Советского Союза». And that comes with this map, which is a work of art, in which every single little dot there, let's see if I can use this pointer. No, sorry. I may need some help here. Hello? I need some help with the... Oh, this is the pointer here. Okay. Each one of these dots, let's see if this pointer is not working, but each one of those little red dots is a silica cap. And if you go in the field, they are actually there. So the Soviets had a really good idea of that by the 1960s. But that started, that understanding of these lithocaps started well before the 1960s. Same Nakovnik, back in the 30s, he was co-managing the exploration at Kunrad. And in 36 or 37, he published a previous paper to the Вторичной кварците, which is the Месторождение Kunrad, where he already had a tremendous understanding of how these silica caps, these lithocaps, can be zoned in a way that is not visibly mappable, but they would do Röntgen analysis, XRD analysis, and once they got those results, go and follow up in the field, and were able to really understand the zoning in these deposits, and were able to use that understanding of the zoning to efficiently target mineralized zones in the Kunrad. And by the 1950s, Nakovnik and his team had 10 different mineral assemblages mapped in the Balkhash area in Kazakhstan. In the West, it took us a long time to catch up with that. We didn't really have any good understanding of these lithocaps until much later. The initial understanding was in the late 1960s when there were some experiments. So in the laboratory, there were geologists that were synthesizing an acid solution that would dissolve the rocks and produce the lithocap type alteration minerals. But it was really only since the discovery of the El Indio deposit in Chile, this is a high sulfidation gold deposit, that it became obvious why those experiments from the laboratory were important. A very rich gold deposit hosted in these rocks that previously were thought of as being just barren, because the majority of them are barren. We need to find those feeders to be able to find the mineralization. El Indio being discovered in the late 1970s. By 1980, we start to get some mapping of lithocaps done in the U.S. and publications on that. There's the classical one is Stephen and Ratte. We're mapping in southern U.S. And here there are two cross-sections. Both of these are cross-sections. On the right, there's a full cross-section showing in red in the center that feeder, which the fluids, these very acid fluids with hydrofluoric acid, hydrochloric acid, nitric acid, go through and dissolve everything and leave nothing but silica. And it looks like a sponge. It has holes, bugs in it from the minerals that were expelled. And the cross-section on the left shows the same thing, but from the center of the feeder outwards to several kilometers away. All of the potassium, sodium, calcium, magnesium, manganese that was in the rocks gets expelled and goes precipitate often kilometers away into that green zone there, on the leftmost green zone, which is the propylitic zone. In the central feeder corridor and around it, it's much too acid for any ferromagnesian minerals to precipitate. So there is this lateral zonation that is shown on the cross-section on the left that decurs from the fluids moving sideways and interacting with the rock and gradually losing their acid component, gradually becoming more reduced and less damaging to the rock. So we see vuggy silica in the center, nothing but silica survives. A little bit farther out, we have alunite and dicite, still very acid minerals. A bit farther out, kaolinite, a little less, but still acid. And way farther away, we get the things that are the minerals that survive only outside of acid environments, which is the propylitic alteration. So besides having this lateral zonation, there's also a vertical zonation, and that's what's illustrated on the cross-section on the right. At the top, surrounding that vuggy silica feeder, there's quartz, alunite, and dicite. These are lower temperature but very acid minerals. Farther down, we get into pyrophyllite, diaspore, dicite. These are a lot hotter. In epithermal deposits, typically the pyrophyllite zone is too hot for gold to precipitate. Gold tends to favor that zone farther up, which is that precipitated at lower temperatures, which is the alunite dicite zone. And if we go even farther down, then we get into the sericitic zone, elite muscovite. We're getting into the porphyry zone. So all of these minerals that are listed here, visually, they're not identifiable. We cannot see. We can see the silicification in the field. We see it's actually residual silica rather than silicification, rather than added silica. So what we see in the field is silica, and the way to recognize it is traditionally in the Soviet time was with XRD analysis. And nowadays, we have infrared spectral analysis to save us in that. This came up, started with Landsat program. Landsat's been the longest living Earth observation program. Now NASA in the US, they launched the first Landsat satellite in 1972, and the geologists started to use it, and they realized very quickly that they can map rocks remotely. They started to compile reference libraries to contrast the spectra of each pixel to be able to identify. But Landsat is a very precarious detector for mineral identifications. Back in 1972, it was the best. It was the best available, of course, but it's very limited. Landsat is still very limited for mineral identifications. So the geologists who were working with remote sensing mineralogy, they started to look for ways to calibrate, to fine-tune those interpretations from Landsat, and they started to look at infrared spectrometers. They came up with the first one that was marketed to geologists, which was the PIMA, the one on the upper right in a black and white photo. The PIMA is a pretty robust instrument, but very primitive. It was not invented for geologists. The technology, infrared spectroscopy, had been developed by astronomers in the 1800s and has been used across the industries. Got really big in the 1950s, so this was around, but this PIMA was the first one that was actually marketed to geologists. So in the software DOS, it originally ran in DOS, but with DOS there was a spectral library. They input the USGS spectral library so that it was easy for geologists to automatically identify minerals. It wasn't yet automatic, but it was possible to identify minerals on a search match, manually choosing something from the library, visually comparing the minerals in the library, the reference library, to your unknown sample. Then in the early 2000s, an American company, infrared spectroscopy company, realized that geologists were paying a fortune for this old junk that was a PIMA. It's not junk. It actually produces very good spectra. I still see some of these in operation in South America, and the spectra are really good. It's just very old technology. And so this American company decided they could sell much nicer spectrometers for the same overpriced fortune. And they came up with the TerraSpec. Many of those are still around. And then other companies caught up with that, and there's OrExpress, there's several other companies that are targeting, that are producing spectrometers specifically for geologists. But in the early 2000s, the problem with this was that we now had the instruments, even though they were overpriced relative to the cost of these instruments in other industries, but they were available. And the mineral reference library was available, but there was nothing to really help to automate that mineral interpretation. We had to learn. I learned to look at the squiggly lines that come out of the spectrometer and be able to identify 1 or 2 or 3, sometimes 5 minerals in that. So that was a real bottleneck that reduced how many people, how many projects could use that. You needed an expert. In South America, we call those spectral experts, we call them PIMologists. And then we got some even fancier equipment, gun-shaped infrared spectrometers that you can take. I don't recommend taking these on traverses in the field, particularly if you're working in lithocaps in the Balhash area. You have some steep outcrops. You will stumble and fall. Every geologist does. And one of these things cannot take a tumble and fall. They are sensitive. They're very fragile instruments. They're laboratory instruments. But if you work on an open pit, then that's the perfect place for that kind of instrument. And it was really really in around 2008, 2010 is when the software started to be available to replace that PMologist, to now make this technology available not only to those who had access to an expert spectral geologist, but to anybody. It started with CSIRO producing the spectral geologist and making it available. It is a paid software, but it's not a very expensive one. You import all your spectra there, and it automatically gives you the mineral identifications. Besides the mineral identifications, we can program it to extract a lot of numerical data that in many cases are even more important than the mineral identifications themselves. Other companies outside of geology, there are many companies that produce software that can do the same thing. It just doesn't come with the inbuilt USGS spectral library. So software like GRAMS is the most used one in spectroscopy around the world. EFTRI is also very good. Predictaria recently came with what I currently consider the best infrared spectroscopy software for imagery, not for points data. So I'll get into the imagery pretty soon. But besides that, there are laboratory services where you can, if you have a spectrometer, your team has a spectrometer collecting data, you can upload those data to their web portal, and it will automatically do the mineral interpretations and give you back not only mineral interpretations, but numerical values that are going to be very useful for targeting exploration, and also a series of analytical graphs. ALS is one of the users of this A-series logarithm. It's an artificial intelligence, a machine learning algorithm that automatically loops through all of the reference library spectrum and chooses the 2 or 3 or 5 best matches to your unknown sample. So at ALS, you can say, I don't work for any of these companies, a disclosure, I don't work for any of these companies, I'm not advertising, but I do like to mention the companies that are doing good work that is useful. At ALS, you can send your drill core or your field samples to be analyzed geochemically, and you can request, along with the geochemical analysis, that they do infrared spectral analysis. So you don't even need to have a spectrometer in camp. You can just get it done in the laboratory. They'll do the analysis, and they will run this A-series software, this logarithm, it's not software, it's a logarithm, a machine learning algorithm that will do the mineral identifications. Another company that is providing really good service, Geotech, and they are here, so I invite you to go visit them. Again, I don't work for them, but one interesting thing they've done is they put a TerraSpec spectrometer on a conveyor that glides above your drill core, and slowly moves above, and you can define what spacing you want between your sample points. So you can define, well, I want a spectrum every centimeter, or a spectrum every 5 millimeters, right? And it'll take point, collect all this point data. It's fast, and it doesn't produce a huge amount of data. We can actually use these data in a personal laptop. So it's a really nice one. Besides that, Geotech also does scanning, infrared scanning of drill core. And now I'm starting to get into the infrared scanning. That's a technology that is getting more and more popular. We see it a lot in the mines, particularly in South America, in places where there are a lot of lithocaps, where we need to distinguish these minerals. The companies will send a full container to the mine or to the core shed, and there the drill core, the boxes go inside the container and get analyzed. Some of them will offer only infrared spectral analysis, but most of the companies by now are offering infrared spectral analysis along with geochemical analysis with LIBS, XRF. The trouble there is that we can scan scan about 1,000 meters of drill core in a day for infrared spectral analysis and get those results of the minerals, right? So that's really efficient. That cuts down a lot of the logging work from the geologists. The geologists still have to verify, and they can use those results to train their eyes to see very subtle alteration minerals, to see lithologies. But as soon as we want to get the geochemical elements along with this in the scanning process, then the maximum we can do nowadays is about 200 meters a day, and even that is pushing it. So there, it slows down the process. So what do we get from these scans of drill core? And not only drill core, but let's start with the drill core. We get these images that are really mineral maps. If we look at these images, we can see very well where there are cross-cutting relationships, where there are alteration features that are specifically associated with a vein, and where they are cross-cutting other pre-existing alteration assemblages. So this is really useful, but it's a huge amount of data. It's a tsunami of data. It does not fit a laptop computer. So once companies that start getting into this technology, they start getting into cloud computing. You need to look into cloud computing for that. And besides the infrared spectra, we also have, at the same time, this also collects visible imagery, and that can be used to log on, because all of this is georeferenced. So once you get that on a tablet, you get that image on a tablet, and you point at any point on the photograph, and it automatically opens, the software will automatically open a line with the depth. So you no longer have to, like 2025 this year, we should not be measuring core with the tape, right? This is a much more efficient way to work in the core sheds. We also get the visible image that we can use to log on. And most systems will have some other things on top: magnetic susceptibility, tomography to get SG measurements, much more precise SG, specific gravity measurements, than those that would get covering the core with wax and dipping it in water. Besides exploration, this is used in mines. It's getting more and more used in mines. Not so much for exploration, but for geometallurgical and geotech purposes. For geotechnical engineers and rock mechanics engineers, their worst nightmare is a fault that has a lot of alteration, that the alteration itself weakens the rock. So it's very important to domain the faults and the alteration around it, but it's also very important to distinguish the domains where the alteration around the rock, the fault, actually strengthen the rock. For instance, if the alteration is silicification around the rock, that's a strong rock. So that is a domain, a geotechnical domain, but the geotechnical domains that we're concerned with are the ones that the fault is surrounded by very, very fragile alteration mineral, the sericites, the clays. And for geometallurgy, this is also very useful, because having this information flowing on a daily basis from the mine, that allows the geometallurgical engineers, the processing engineers, to better plan how they're going to stockpile the feed from the different ore from the different parts, from the different geotechnical domains, in the end, so that they blend it in the way that the very clay-rich zones are not going to plug the mill, because it's blended with other. It's so that they can plan in advance for the zones that need specific special grinding techniques. So the evolution of this understanding of lithocaps that led into this tangent on infrared spectral technology from all the way from the lithocaps to current machine learning methods, we went a huge way in terms of technology. But the interesting thing is that in spite of this huge leap in technology, our understanding of the lithocaps today, our knowledge of how the minerals are distributed, hasn't evolved much since Nakovnik. So, because there's not much to evolve. The Soviets really had it down. They had it without AI, without spectroscopy, without any of these fancy methods that we had. They had it all figured out. So that is it for my lithocap presentation. I would just like to take the last minute to let you know that the Society of Economic Geologists, for which I represent, I'm a representative for Central Asia. We are an association that promotes knowledge, geological knowledge, and we particularly favor young career geologists and students. We have a lot of funding for young career students to go to conferences, to travel, to do field trips, to organize their own field trips. And we do this, all of us are volunteers. We have, last year we held a conference in Namibia, and all of the African students who came to the conference, it was a big conference, as big as this, and all of the African students were paid by the SEG to attend the conference, all their travel fees were paid. So if you know students in Kazakhstan who are looking for better opportunities, if you're a professional or a young geologist, young professional, please take these codes and look at the SEG, what we have to offer. Thank you very much.